1559. I'm here as a presenter of group number 3. We have given assignment to discuss how can we touch
represent
some of the concepts related to electrodynamics. For our groups, we have chosen to talk about one of the concepts found in electrodynamics, which is called optical fiber.
Yes.
We are going to discuss about optical fiber. Here there is running outcomes, what you have to know after this lesson. After this lesson, you will be able to describe fiber optics and fiber optic communication. The second, you will be able to list the parts of fiber optics data means you will link the fiber optics and its data, or the data that can be transmitted through optical fibers. The next, you will understand the function of each part of optical fiber. The third one, you will discuss about the application of optical fiber in real life situation. Firstly, here there is pair activity. Pair activity you are going to do in your pairs as you are sitting. We are going to discuss how does a video call travel from your phone to someone in another country in a second. You know, we all familiar with different technologies such as video calls. When you are talking with someone through video calls, how does the sound, even the video, travel in a second? The second one we will discuss, why is the internet faster in some homes than others? And what do you think carries information across oceans? You know, we have different continents. Here we are in the continent of Africa. You know, there is another continent such as America. Right now, you can talk to someone who is in America via phone. How does those information be carried across the oceans? The next one, fiber optics is a technology that transmits information right through very thin, flexible thread made from glass. But first, before we proceed to this definition, join your pairs and discuss about those 3 questions. Discuss. Mr. Sam, can you help us to answer this first question? How does video call travel from your phone to someone who is abroad?
Okay, so on my side, or according to how I understand things, so the video is transmitted through the means of electric signals. That's to mean the video call, the one who is receiving the call or the call between the 2 people is done through electric signals transmission.
Okay, very good. Let us clap for him. Okay. That is what we are going to deal with. That's what we are going to discuss about electrical signals transmission. I'm going to invite Mr. Spirit to proceed by explaining the components of optical fibers. Thank you.
Thanks. Morning once again.
morning.
My name is Imani Ospriye with leg number 2230 904. Now we are going to continue with the structure of optical fiber. This optical fiber consists of 3 main parts as indicated on this diagram, where we have a fiber core, a fiber clothing and a jacket. The core carry optical fiber that electrical signals transmit through the internal part, which is the optical core. Then the outer part is the cladding surround the core and it has a slight lower refractive index. Other part is protective jacket. This part is made of materials like polyethylene to shield the bar from damage and the moisture. Moisture, moisture is a wetness of environment. And the signal propagates through the core by total internal reflection at the core clothing bar boundary. Then let me allow other of my colleagues to continue with the principles of operations of optical fibers.
Okay, thank you so much. Hello. Hi. I'm Sumile Kabusenga with leg number 2-15-39-6. So we are proceeding with the principles of operation of optical fiber. Before, let us have a look on this. The operation is about total internal reflection, and light is guided in an optical fiber at a certain angle, which is called acceptance angle. But before, I have something for you. I'm saying total internal reflection, but somehow it's not visible. Then we are going to have it visible. Let me use this torch. Then we are having water in the bottle, and then, as you know, this is air. Air with refractive index of 1. Yes. Then water with refractive index of 1.33.
Yes.
So you can see the difference. Then when I shine the torch inside the water, let us see. Because we have the denser medium is the water, of course. Then now I can see the light is totally inside the water, okay?
Yes.
It's totally staying inside the bottle. Means that we are having no light outside it. That is what we call total internal reflection. It is not observed all of the time because there is a condition, of course. We have a condition on the angle. So we have a signal. This is a part of an optical fiber. We have, for example, we have taken a part of it. Then suppose this is a signal. This is an angle which we are indicating as theta A. Also, when we have the reflectivity so in the air, then in the core, this is the core with reflective index NF. Then you have cladding here with reflective index of NC. And as you know, this is greater than this and greater than this one. It means that we are going to have reflection. This is signal will be reflected by at this angle, theta B, and also it will be an incidence to this interface.
Yes.
And we are having then theta C. To have total internal reflection, this angle we are putting here should be greater than this theta C, so that we will be having total internal reflection like this one from this manner. So, from this diagram, using Snell's law, by Snell's law, you know that we are going to have N0 0 sine theta A, which is equal to NF sine theta B, according to Snell's law. Also, when you reach here at critical angle, we are going to have NF sine theta C, which is equal to NC sine. Because in the critical angle they imagine the angle is equal to 90 degrees. We are going to have one here, okay? So therefore, sine theta C is going to be equal to NC by NF. Then, from here, from this triangle, you can see that sine theta C is equal to cos theta B, okay? Because if we have, for example, y and x, we are going to have x squared plus y squared, okay?
Yes.
Then, when you calculate the sine for theta C, sine, you're going to have y by this one, okay?
Yes.
And cos theta B is also y by this one.
Oh.
So if you observe that this is equal to this one.
Yes.
Then from this one, doing many calculations, you are going to observe that sine theta H will be equal to NF minus NC square by NO. Sine theta A. Remember, this is called acceptance angle. And all over this one will be given a name of numerical aperture, okay, which is a quantity corresponding to a wideness where the signal is entering the core. Then there will be a continual movement or carry of the signal over long distance. Remember, may correct to continue with the next topics. Thank you. With advantages.
Good morning.
Good morning, Jean-Pierre.
How are you?
Yeah, fine.
I'm Jean-Pierre Uwase with legislation number 2230-10-313, and we are going to continue with the interesting topic about the advantage and disadvantage of optical fiber. Have you heard about how Jose was saying that how do we video call people from America when we are in Rwanda? And you have, with the SAM, you have been talking about how light travel within the fiber doing total internal reflection. Do you think that with all that, optical fibers are very important?
Yes.
Do you think? How?
Because they help us to carry the signal from one place.
Okay, thank you very much. By like group assignment or group work, you are going to do it as you sit in the line. You are going to discuss only one advantage and one disadvantage of optical fiber. And then we are going to come through it while you have discussed about it collaboratively.
Yes.
I want all of you to collaborate.
Yes.
Discuss, okay?
Yes.
Also discuss advantage and disadvantage of optical fibers, okay?
Another disadvantage.
Wow, you are collaborating. Thank you so much. And I want you to share us what you have discussed about. Joshua, have you found something as the advantage of optical fiber?
Yes, we tried our best.
What is it then?
Okay, in our pair we have discussed that one of the advantage of optical fiber, it transmits information fast rather than other communication channels.
Higher transmission.
Yes.
Yes.
Kevin, is there anything you can add on as the advantage of optical fiber?
No problem.
What is it?
I can add it, no problem.
Yes, go on.
Okay. As the children have said that optical fibers can add more information rather than the others. Here I can add another thing. It can signals effectively.
And then we are going to continue with the disadvantage. Olivier, do you have any disadvantage of optical fibers?
Of course, there are.
Yes.
For me, I think in the angle of cost, this is too costly.
Wow, thank you so much. Kosti. Nadine, any disadvantage of optical fibers? You don't have? Janine, any disadvantage? Okay, Mr. Gilbert, any disadvantage?
Yes, me, I want to talk about attenuation
Attenuation?
that we have when information is propagating through the fiber may suffer from attenuation. That's one of the advantages of optical fiber.
Okay, thank you so much for your collaborative group work. And what I can say about it, for disadvantage, it carries large information and it can travel a very long distance, okay?
Yes.
And also, since it doesn't involve using electricity, it doesn't contain those hazards of fire or what, okay? Also about the disadvantage, I can say that because it uses glass, core use glass, it is very fragile. Yeah, thus if not handled well, it can break down due to bending or what. Also, in remote areas, their availability is very limited since it is costly. Also, it requires skilled laborers and what. So, thank you so much for your kind attention. Let me just welcome another member to
Morning again. My name is Tukumana Janda, registration number 223009823. So we are going to make the summary of what we have been done. So it's not me who is going to make summary, it's you who are going to make the summary of what we have been discussing. So in a few, what we have we learned? Sam, what have we learned? Sam Hategekimana. Okay, we have the two people called Sam.
Okay, so we have studied the fiber optics, where we have seen its advantages and disadvantages. The one I remember is that for fiber optics, when it is used in communication, there is faster transmission of signals, and about the disadvantage, there is the possibility of attenuation or signal loss, and also it is not cost effective as the equipment needed to set that is costly.
Okay, thank you for. I see. I have seen that you are flowing. So, in order to summarize it, let's use it like a problem situation. For example, an MTN communication company is going to transmit that information, data information from one point to another, and what are the environment constraints which can happen during that transmission? What are the environment? For example, if they have to transmit data from one point here up to other, and for example, between those points, there are water. For example, there is like a cable between 2 points. What do you think that are the environmental constraints which can affect that communication? Jean-Pierre?
Maybe long distance.
Maybe longer distance. So what do you think can we use to solve that problem, Olivier? Between copper wires and optical fibers, what do you think may be better? What do you think, Olivier?
For me,
For solving that problem of longer distance.
yeah, in regard to what I already know, I think we can use optical fibers because even now in Rwanda we use the one from China.
We can use the optical fibers. Why do you think we must use the optical fibers? Jibat, why can we choose optical fibers rather than?
I think we have seen that we can choose optical fibers because they are more effective than other means of communication.
Yeah, thank you. We can choose optical fibers because we have seen that due to the use of the principle of total internal reflection, there is no information loss. And the optical fibers, they are very good according to the environment. For example, due to the funding, they may be friendly rather than those copper wires. So thank you. Let me invite other colleagues.
My name is Wimbo Semis. My leg number 223011719. According to what we have run, we can able to answer this question. First question concerning the following statement. A fiber optical cable is much light than B. Everyone can see it.
Yes.
So who has the solution of question 1? Who has the solution of question 1? So can you try to answer this question?
I think the correct answer is B.
B. Why?
Because for me, I think that optical fiber cables is not affect the power of stranger of electromagnetic interference.
Thank you, Riso. Question number 2.